In this video, we are going to walk you through, at a very high level, the technical aspects of this cloud running on Power in your data center on your systems. To provide some context, the big difference between this cloud and a public cloud is that, unlike a public cloud where you do not own the infrastructure and you do not control that, because this cloud is running on your systems in your data center, systems that you have already paid for, you have complete control over every variable, and that is the objective of what I'm going to show you today. So, cloud computing, what is it? Cloud computing, at its most essential, is the abstraction, or also referred to as the act of software defining all your hardware so that it can be automated, and as a result of that, it provides self-service, on-demand capabilities. And so what do we mean by software defining your hardware? When the cloud is installed, all your hardware that will be presented to the cloud will be seen in these three icons. So first of all, your hosts. This particular cloud has two servers. And again, our demo environments are limited, but suffice it to say that if you use the hardware management console, or HMC, you can have up to 30 servers here. If you need more, then you use Novalink, which can support up to 200 servers. So that tells you how big this cloud can be. It can run a whole enterprise. In this environment, we are limited to two servers, CPT and leg, and you can see all the attributes with these servers, including virtual machines and so on. Then I take you to host groups. A host group, which is also known as a host aggregate in OpenStack, allows you to create virtual boundaries around a group of hosts. It also lets you logically partition your hosts. Why is this important? An enterprise can benefit in many ways from using host groups. Number one, it can logically separate groups of hosts based on business need. For example, you might create separate host groups for test, development, and production. Additionally, you can realize infrastructure as a service level agreements. For example, one host group might use high-end storage while a different host group uses commodity storage. So this aspect of host groups gives you a sense for how much control you have and how you can dictate policies and how your hardware is utilized down to very granular levels, and how you can manage SLAs, which allow you to then more effectively recover your costs. HMC connections, or hardware management console connections, because in this case we are running this whole system from HMC, allows high redundancy from the perspective that, as you can see here, for example, you've got HMC CPT, which is the one server, and then you've got a secondary HMC CPT2. If this was to fail, HMC CPT2 would take over without human intervention, and you can see that they have two different IP addresses. So that allows you to maximize one of the natures of cloud computing, which is high fault tolerance. As we move to networks, this particular cloud has one network, which was abstracted, and it is used for computing, as you can see here. And as you get more networks, you can add more. Please note that when we stand up this cloud for you, all of this will be done by the services provider that does that work for you. And finally, the storage hardware is also software defined. We happen to have two environments here. One is SVC. The other one is a VMware environment, which unfortunately right now is not working, but you see it immediately here. And then as you get more, then you can add more storage here. Your fabrics are how this is connected. This happens to be connected using Brocade in this particular demo. You have service nodes, you have data volumes, and then you have boot volumes for your different environments. So here is an AIX environment, here's a Red Hat Linux environment, here's a System I environment. So that's how this is provisioned. So that's the hardware defined in software. Now with this, you still cannot do computing yet until you create images. So an image brings together all the computing elements so that you can actually do computing. So just to give you an example here, here's a Red Hat image, and what a Red Hat image has, it has a name, it has a status, so it's active, it has an ID, it has a visibility, it gives you information about when it was created, but then the specifications are a container format is bare, a disk format is raw, operating system is Red Hat Linux, it's got a hypervisor assigned to it. In this case, it's Power VM. It's got the architecture 64-bit. Endianness is little endian. It's got a volume assigned to it, and this is a boot volume, as you can see here. And so once you create the image, you now have brought together all the aspects required to do computing. To cap this off, you create deploy templates. What deploy templates are, an even further level of control for you, where you can, using an image, you can then assign the attributes that eventually will become a VM. So notice here we've got an AIX template small, a System I small template, a Red Hat small template, and a Red Hat large template. Then you can see the number of processors assigned, the memory assigned. And what this does for you, it standardizes what users can create so that your system becomes far more stable and predictable in how you use resources. And so if I take you to, for example, the Red Hat Linux template, when a developer wants to request a VM, they will go to a deploy template, and those are the only choices that that person will be given. And this has all the attributes required to enable the VM. So notice that every deploy template is tied to an image. So I just walk you through that image. Here's where all the computing will happen. The deploy target is the host that it will run on. So if you recall, you have CPT and leg. This one will run on leg. It has a storage connectivity group, and then it has the specifications of the attributes, the computing attributes of this particular VM. So for example, it's got one processor. You will be allowed to use 8 gigabytes of memory. You have a number of virtual processors with a minimum, a maximum. You've got a minimum memory and a maximum memory. You got desired processing units. And so what this does, it allows you to control how many resources are given to the user. Additionally, what this creates is speed and convenience for the users, because imagine how difficult it would be and what a waste of time it would be if every time a user wanted to deploy a VM, they had to go through each one of these variables and set them up. This clearly makes it very easy for them, because when they go to request a template, they just look at it. If this fits their needs, they just click deploy. And you can see that in my other article where I show you how easy it is to deploy a template in 2 minutes. And so what I've just walked you through is a real cloud with all the elements that a cloud uses. Finally, the other thing I'm going to walk you through is DRO events. What is DRO? DRO stands for Dynamic Resource Optimizer. The IBM Power VC Dynamic Resource Optimizer is continuously monitoring the resource utilization of physical hosts and virtual machines in a cloud environment. When the DRO detects a usage imbalance, the DRO will optimize the cloud by making adjustments for workloads whose characteristics change over time. So what can a DRO do for you? DRO's automated processes save you time by automating optimization in your environment and by giving you an easy way to view those changes. DRO allows you to do the following. Set up a DRO to monitor your cloud's utilization and address either CPU or memory resource imbalances. Specify different acceptance levels of usage for each host group. Run DRO in advise mode to see where usage problems are occurring without letting DRO act on your environment. Take advantage of Power Systems Enterprise Pool Computing on Demand licenses by assigning cores or mobile memory to overburdened hosts, and that only works with enterprise servers, by the way. Exclude specific hosts or virtual machine to control which resources are optimized and ensure that mission-critical virtual machines are not migrated. Easily see which hosts are in violation of the optimization policy, so you know which hosts are subject to DRO operations. So as you can see here, this is an example of hosts that are in violation of an optimization policy that IT operations set up. So this is an indication that this has to be revisited. So in this example, IT operations set a policy that the utilization threshold is 6%, and this CPU utilization is at 10.44. So if you want more details or you want an in-depth technical discussion, please connect with us. Thank you very much.